Welcome to the Enterprise Excellence Podcast, where our purpose is to help create a better future. Learn from our world's experts how to improve your organisation sustainably. Learn how to achieve and sustain an excellence journey for yourself, others, and the planet.
And I'm your host, Brad Jevons, coming to you from Brisbane, Australia. We are proudly brought to you in association with SA Partners, a world-leading business transformation consultancy. SA Partners are a truly purposeful company focused on helping organisations achieve sustainable improvement for themselves, others, and the planet. Welcome to episode 99 of the Enterprise Excellence Podcast. It is such a pleasure to have Dr. Rajesh Jugulum on the show with us today to discuss his most recent book, Common Data Sense for Professionals, a process-oriented approach for data science projects. Dr. Rajesh, already the author of 6 books on many topics of enterprise excellence. He is a data science, analytics, and process engineering leader. He has held executive positions in large corporations related to healthcare and finance. Dr. Rajesh teaches at the Northeastern University, Boston, as an affiliate professor. I'm looking forward to this conversation. Let's get into the episode. Dr. Rajesh, thank you so much for joining us today.
Thank you so much, Brad, for having me.
Yeah, really appreciate it. Rajesh, what's your backstory? Like, what significant moments led you down this path of getting involved in everything to do with enterprise excellence, and especially around the data and analytics side of things?
Yeah, from my childhood, I have been interested in mathematics. So, though I have a basic degree in mechanical engineering, the significant moment came when I joined Indian Statistical Institute for my master's degree. I finished Master of Technology there, and I was fascinated by contributions of P.C. Mahalanobis, C.R. Rao, Genichi Taguchi. So that led me to be pursue my career in data and analytics. And in that process, I was also doing process engineering work, focusing on Six Sigma, because that is also statistical based process framework. So I think if you ask me about the significant moment, joining Indian Statistical Institute, that's when I got interested in these topics.
Oh, great. So Rajesh, it's really, I guess it started early on with that focus on mathematics and then into engineering and on to Six Sigma, which I guess the two connect together well, don't they? You know, the data analytics side and then the structures of Six Sigma. Is that what you found? Was it like a perfect marriage between the two for you?
Yeah, exactly. Because if you think about how process engineering and data science operate in industry, they operate in silos. And there is no communication between those two disciplines. So I think it's important for us to have these two fields come together. And for solving data science problem, what I'm not seeing is having a structured approach to solve the problems. I think bridging the gap between process field and data field would help us to have a disciplined approach to solve data science problems.
Yeah, it's too true, isn't it? Like often in that data science field, it's like people can be running off down rabbit warrens for different types of data at different times for whatever's needed or wanted at the time. Whereas that structure of like the Six Sigma DMAIC style thinking and everything that goes with it brings that structure to keep it more precise and to the point and create focus, I guess.
Exactly. Yeah, it will create focus, and it will also help us to formulate the problem that we are trying to solve more clearly. That way we get the correct data to solve the problems.
Yeah, that's neat. Yeah, so what inspired you to write this most recent book, Common Data Sense for Professionals?
The inspiration, if you ask me about inspiration, like I said, right, the data and process, because I worked in big corporations and I saw this gap between process engineering and data science. So I wanted to do my part by way of contributing to sketch out a process to solve the data science problems. That's important. And moreover, if you think about regular business people, right, if you talk to them about data science or data analytics, there is a tendency, like they get intimidated to hear these words. Like they think data science or data analytics projects are meant for advanced degree holders and people with good mathematical background, all those things. So there is that kind of fear in regular business people, although they are the main business data users. So if you think about that, and in order to make everybody to enjoy the benefits of data, because everybody is working with a lot of data, we need to drive out that fear. So that is another inspiration I had. That's the other inspiration using that inspiration based on which this book was written. And third thing is H.G. Wells long ago predicted. He said that statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. So we have this is the right time to make that reality, because we have so much data. People can use the data, they can solve the problems, they can understand the benefits of the problem, so that it's more like a data democratization.
Yeah, that's nice. So it's really shifting the ability and knowledge to use data effectively away from a few, as traditionally, into the general business and general day-to-day is the purpose behind your book and what you've written.
Exactly. That is the core message. Yeah, you perfectly articulated it.
Oh, thanks, Rajesh. Well, it's certainly needed, isn't it? Because I guess, what do you see generally in business, Rajesh? Do you see a lot of decisions being made without data behind it, or without taking the time to actually delve into a situation or a challenge deeply?
Yeah, I still think, although we have a lot of the decisions should be based on insights, and people are still, they are using their intuition to make decisions. And a lot of times, as one of the famous statistician told, a lot of times people use statistics to support their decision rather than making decision based on statistics.
Ah,
And they say, I have the answer, give me statistics to substantiate it. So that's what is happening. So that should change, because if you have data, if you know what problem you are addressing or solving, take the correct data, make the data is fit for the intended purpose. That's important. That is where the data quality comes into play. Then use the data, and based on which you make the decisions. So that is what is a missing piece here. Because although a lot of people talk about, okay, we want to make data driven decisions, we want to be analytical driven, and a lot of times that's not happening in reality, because I don't know, people still tend to make decisions based on intuition, or they want to support their decisions with the data.
yeah, got you. So it's flipping that, where we have a problem or we have a potential decision we've got to make, and we go to the data first and then draw insights and knowledge from that to then make decisions. Whereas I can even reflect on my own career, Rajesh, there's been times where I've made a decision and then looked for data to support that decision. It's too true.
Yeah.
Yeah. So
Yeah.
Rajesh, what are the key takeaways and elements of the book that readers can get to really help them shift to a place of using data more effectively to be able to make accurate decisions and great
Yeah.
paths forward?
This book focuses on couple of important things. One is, it is intended for anybody to use to work on data related projects and get benefits, so that they don't need to be scared thinking that they don't have data advanced degrees, things like that. And the book focuses on this, like you need to make sure you know what problem you are working for. Like, you need to define the problem clearly. That's an important thing. And once you have that problem definition correct, then you also need a structure to solve the data science problems. So that's, without structure, it's impossible, or it's very hard to solve data science problems. So the structure is based on three important steps. One is understanding the problem. That's where problem definition is important. And the second thing is, once you know once you understand what problem you're solving, then collecting the relevant data. You need to know what data needs to be collected corresponding to the problem you are addressing. Then data collection and understanding the data quality issues, and making sure the data is fit for the intended purpose. That is the second stage. Once that happens, then what happens is, you can also look at various risk aspects, like what degree of confidence we have in data for usage, those kind of things. Then you can select a suitable framework or analytical model to solve the problem, to analyze the model, and deploy those analytical results to decision-making in decision-making activities. So in order to make sure that we have right analytical insights, we need to conduct some kind of a model validation. The model validation is not traditional statistical validation. It's basically what is the analytical output and what is the actual outcome, and look at the gap between analytical output and actual outcome. And as long as that gap is small, then your model is good. Then you can deploy it in actual in the decision making activities. If the gap is large, then you may have to revisit and see, maybe do you have the right data, or do you have the right kind of variables? All those things need to be looked into.
Good. Rajesh, with defining the problem, what would you recommend to listeners as a really simple, great practice way to effectively define a problem?
So problem definition, right? It should be specific to what we are addressing, and it should be, you should also that should be measurable, specific and measurable, and it should be it should be easy to act upon, and it should have time bound, like we should be solving this problem in 3 months or 6 months, whatever it is. If it is a complex problem, maybe 1 year. We need to have the time aspect into the problem definition.
Okay. Yeah, that I can hear that comes back to that SMART type thinking, isn't it? Specific, measurable, achievable, relevant, timely type.
Exactly. Thing. Yeah, it's in the same lines. Yeah.
Okay, so you're setting up the problem, and you're defining it, and you're making it specific, measurable, achievable, relevant, timely for that path forward. What's some of the better data collection techniques then? So you're going to then go into the measurement phase and actually measure and look to truly understand the problem. What's some great techniques there that you write about and you'd recommend to listeners?
The data collection techniques, basically, like one thing is like it depends. Like once, let us say, if you want to improve profitability, right? And that's a metric you are trying to use. So you need to have the right kind of metric, the profitability metric. And profitability is more like in statistical terms, is a dependent variable. It's influenced by several attributes, right? Several variables, like it should be customer behavior patterns and the location where the service facility is there, those kind of things. So all those attributes should be understood clearly, and you need to collect the data corresponding to those attributes. So looking at the understanding everything, like if you start with a good problem definition, you know what data need to be collected. For example, if you think about profitability or whatever it is, then corresponding to it, we need to identify what are the factors or attributes that are impacting that, and collect the data for those attributes. So sometimes some attributes are controllable, some are not. But I think I worked with Dr. Taguchi. He differentiates them as controllable factors and noise factors. So even if it is non-controllable or noise factors, but we need to know they exist in the process, and they need to be handled in a different way.
Well, Rajesh, with what you're describing, I'm sort of putting the problem statement defining the problem as like the top of like a causal tree in a way, and you're defining it as like profitability. And then you're looking at what factors feed into that.
Exactly.
So it's a bit like a cause tree or a taproot causal factor, and then you're looking at which ones of these can we actually control, or which ones are out of our control. That's pretty neat. Yes. So it really allows you to sort of see the forest for the trees, doesn't it? Because you're going, okay, so what's the problem? Okay, so what's everything that could contribute to that? What's the leading factors driving into that? That's neat.
Yeah.
When I was first involved in deploying enterprise excellence, I gained so much from being able to connect with global experts like Chris Butterworth, Alex Teo, and Peter Hines. They shared their knowledge, but they also inspired me to keep moving forward and played a big part in what I'm doing now. We can now offer this same opportunity to many of our listeners. We are currently forming the Enterprise Excellence Community. This community is for people practically deploying an excellence journey within their enterprise. The community allows us to link directly with our world's experts each month to learn and grow for an hour. We already have Jeff Sutherland, Jeff Leica, Pascal Dennis, Laurent Simon, and Louis Trigger confirmed for the coming months. For the final hour of the gathering, we then link in small groups with our peers to help each other overcome challenges and continue to move forward towards our vision of excellence and goals within our organisation. To get involved or gain more information, reach out via our website, enterpriseexcellencepodcast.com/contact. We look forward to talking to you soon and working together with our world's experts and each other to create a better future.
Rajesh, is there any other techniques you can go deeper to prioritize then, or delve deeper into which factors should be working? Like you think with profitability, there'd be a lot of potential causal or impact factors to that. Is there any techniques to then be able to prioritize where should we put our effort?
Again, if you want to understand, again, that is where we do what you call the root cause analysis, right? What are the factors? You may start off with the potential causes, then you need to identify the root causes. That depends on the situation, and you may look at so many factors and collect the data on the factors, and based on the data, you can determine which of these factors are really critical. Again, that is another data collection process where we have to collect the data on the causes, make sure they are causing the problem, then use them for the final modeling and frameworks.
Too true. So the data, it's really then what can we control? Go look for the data then to give you insights and knowledge, and from there you can analyze it to then think, right, what do we do? Rajesh, with the analysis element of it, is there any key insights that you'd provide around how to best do analysis? You've got your problem statement, you've got the leading factors that contribute to it, you've collected data, done root cause. What's some of the great analysis techniques that can be then used based on that?
Yeah, analysis technique, that before we go into the analytical aspects, right, we have the data on the attributes that we think are going to be causing the issues for the profitability in this example. Then we need to ensure whatever data you collect on the attribute, they're of good quality. So a lot of data quality techniques, and because I worked in companies, I worked in chief data offices, and I led data quality analytics teams, where the focus is to make sure, okay, whatever data you have, right, is it fit for the intended purpose. So when you measure the data quality, right, that there are different dimensions that need to be considered, like timeliness of data, and accuracy of the data, completeness of the data, validity of the data. Those are the different companies have different core dimensions. Considering all those core dimensions, we need to ensure the quality of the data. Once we have the data quality at the satisfactory level, then use the data for the analytical purpose. So when you work on analytical model side, it could be anything, like you can use regression analysis, or some kind of machine learning techniques, or discriminant analysis, and we also have some kind of individualized analytics. Whatever may be the technique you are using, before that, make sure the data is fit for the purpose, and at the same time, you also minimize the risk associated with the data that you are using.
Yeah, I could see, Rajesh, if the quality of data is not there, you could end up making a decision that sends you off down a completely incorrect path.
Yeah.
So the analysis can be completely out of control because you're analyzing poor data, which is leading you to head down, analyze the wrong outcomes and make the wrong decisions.
Exactly. There is a saying, right? Data, I cried. I can't make bricks without clay. I will venture into add one more thing there. Good data, I cried. I cannot make good bricks without good clay.
Yeah, too true. So Rajesh, with it, you've got the data, you've got the right, you've been able to apply some quality techniques to make sure it is quality data, which you mentioned a number of them. What then is seen as like best practice for then actually conducting the analysis to then make decisions and improvement based on?
Once you have the right kind of data, right, the next step is to, okay, the data. Again, this is part of improve phase. If you think about Six Sigma DMAIC approach, like it's in more of an improve phase. I have the data, I measured it, and I know the causes. Then I need to take actions against those causes, and that is the actions on those causes can be taken only if you know how these factors or causes are impacting to the final outcome. So that's why we can fit in models like regression models, or maybe we can use discriminant analysis, understand the impact of each factor to the total outcome. Then make improvements on those factors. Like we can find out what are the significant factors or important variables based on the analytical framework, then use them for taking actions.
Yeah, neat. So there's a number of different techniques you mentioned that can be used to then define, okay, so where should we take our action? Out of this quality information we've got, where is our best shot to take action to then get towards the problem we're trying to solve or the goal we're trying to achieve?
Yeah, and in order to do that, also we need to have a structured approach. Like you have so many techniques, right? Depending on your intent, we have several analytical types, several types of analytics: preparatory analytics, cause-related analytics, prescriptive analytics, predictive analytics, reliability-based analytics, diagnostic analytics. There are several types of analytics, right? Depending on the problem you are trying to solve, once you know the data is of good quality, is fit for the purpose, the next step is to select the suitable framework or analytical technique or framework to solve the problem. That's where having a structured approach to follow to select a suitable technique, all those things, that should be part of the overall data science structured approach.
Yeah, nice. And Rajesh, what do you believe stops organizations effectively taking these steps? Like what? It's powerful, isn't it? Where you can define a problem clearly, conduct really good measurement from that, and ensure it's quality data, create and analyze that effectively, and then predict which path should we take based on data. What stops organizations taking this data analytics approach, I should say?
And a couple of things, right? One is, like I mentioned in the beginning, like data and process. These are looked into as separate functions in a company, like they are working in silos. So the top leadership should try to bridge the gap, like meaning they should come in, they should interact with each other and to solve the problem. That's very important. A lot of people don't know that, because if they think data science is separate field, process engineering is separate field, there is no, they can work in silos. That is not that should not be the case. They should come in and they should interact more and more to solve the problems. And another important thing is, like I said, right, data science should be available to everybody. Like it's more like anybody who, because we have so much data in the world now, and people from them, they deal with the data ever since from the time they wake up in the morning to the time they go to bed. They use a lot of data with all these apps or smart phones. They have a lot of data, and they should be also given freedom to work with the data and solve the problem. So in other words, in order to solve the data problems, right, a lot of times we engage only data scientists, those kind of things, and those kind of people. And in industry, a lot of times data is used by regular business people. So they need to be empowered to work with data and solve the data problem. So I think that thinking, that mindset has to change, because everybody can become data scientist if they wish to, and the company should support that. So more like the senior management should support that activity, and they build that into the process, into the overall activities. They should be able to provide required training and give them necessary tools to solve the problems and necessary support to solve the problems.
Well, just that's really cool, because it links back to your purpose, doesn't it? I guess of the book, which you mentioned, getting the process and data science together to be able to work together as one, but then also get the knowledge out there to the broader organization so that everyone can work with data effectively. And it's great that you've written this book, Common Data Sense for Professionals, that allows anyone who wants to read more deeply and understand this great technique that can be used to really help create good outcomes.
Yeah.
Rajesh, what would be your 2-minute enterprise excellence tip to anyone listening to this show in relation to your area of expertise?
Yeah, 2-minute tip would be again, everybody should think about if they have data, right? Why I am using data rather than just I have some data, put it in some package and get some results. That should not be the intent. Understanding the problem that you want to solve, that's important. And the second thing is people think right now we are in big data era, and they think all data is necessary. So that is not true, right? So we need to make sure what is the relevant data. So my identification of relevant data, big data to relevant data, and relevant data to meaningful insights, and using those insights in the decision making activities so that we can make judicious decisions with more confidence. So problem definition, understanding relevant data. We don't need big data for data analysis, and getting meaningful insights and deploying in decision making activities.
Yeah, that sounds like common data sense to me, Rajesh. It's sort of, especially the bit you mentioned about understanding what is the right data and getting the focus on that space, which you've mentioned throughout the show. Thank you, Rajesh. Rajesh, what's been a recent insight for you that you didn't know before, mate? What's been a recent insight that you've gained from data that really set you back a bit?
A recent insight, that's what I'm, because I was also, maybe if you had asked me this question 5 years ago, I was thinking, okay, I am more into data analytics and process engineering, so I am specialized in this area, so I can only solve these kind of problems. But now, because with the data that is available, and I also talk to a lot of people, they're interested in data and the data science and data related activities. So making sure that everybody who is interested in solving data science problems, they have the right kind of support and right kind of tools to solve the problems. And another thing is, like I said, right, I was also thinking, okay, we need all the data to solve the problem. So that relevant data aspect, understanding what is important for the given problem, what data is important and what is relevant, and making sure that that data is of good quality before using the data in the analytical activities.
Yeah, it's really cool. That's really cool. Rajesh, how can people reach out to you or get hold of the book if they want? Like, I'm sure this book is going to provide a lot of insights to a lot of people.
And book is available on Amazon.com. And if they want if they want to have a conversation with me, I have a website, www.rajeshjugulum.com, where they can I have contact information. They can reach out to me via email using that contact information, or and probably if they have questions, if they fail to find my contact information, I'm assuming they can reach out to you and you can provide the contact information. Yeah,
definitely, Rajesh. Well, Rajesh, thank you so much, mate, for coming on the podcast and sharing knowledge on such a key topic, that will help so many, mate. Thanks for helping us create a better future.
Thank you so much, Brad, for having me, and it was very nice discussing with you. And thanks for your kind support.
Cheers, Rajesh. Bye for now.
Bye for now.
There were 2 key takeaways for me from this episode. Firstly, define the problem clearly and its contributing factors. Whenever we have a problem or a goal we are chasing, it is a lot easier to achieve it if we clearly define and measure it. This creates clarity and a lagging measure we are working towards. The step Rajesh then mentioned to clearly understand the contributing factors to this problem and goal allows us to look into leading elements which we'll be able to influence and control. This approach allows us to focus on understanding the leading factors we can then influence using quality data. The second key takeaway for me was analyze the right data. Rajesh mentioned that the right data is the key to solving any problem. Too much data can cause confusion, reduce clarity, and lead to inaction. The right data that is quality enables us to think clearer and make decisions to move forward. This approach with data allows us to see the forest for the trees, cut through the noise to see what is important and make decisions. Thanks again for your time and knowledge, Rajesh. Thanks for helping us create a better future. Bye for now.